By now, I think we have all used or at least interacted with artificial intelligence systems, whether it is text generation, image generation, video generation, ChatGPT, Gemini, Claude, and the underlying architecture that an intelligence systems uh, use are neural networks. And in this video, we are trying to understand how a neural network learns from data. And this is going to be an oversimplification of neural networks. So please bear with me. Now, in order to understand neural networks, if we even oversimplify that, we have to understand gradient descent. Now, while it may sound complicated, it is very simple. So let's understand gradient descent with an example. So suppose you are a real estate developer and you want to estimate the amount of an apartment based on only one factor, that is the area of the apartment, right? So in an ideal scenario, there might be several factors, but we'll come back to that later on. For now, let's consider that there is only one factor, and that is the area, right? So let's plot a graph, and in the x-axis we have the area, and in the y-axis we have the price, right? And since you are a real estate developer, you already had some pointers of prices in the area, and let's plot them as well, right? So how we will use this gradient descent is basically we will draw a line parallel to the x-axis first. All right. So we know the equation for a straight line is y is equal to ax plus b. And if we draw a line parallel to the x-axis, the value of a is 0, right? Y is equal to b. So now we will measure the distance from that line to the each pointers that we plotted, the each data points we had, right? The prices. And the distance from the line and the data points are known as the loss function. Now, we are trying to minimize this loss function, all right? So we can do that by following, let's say, changing the parameters. Now, I mentioned y is equal to ax plus b, and we'll just try to interchange a and b to get a straight line which has the lowest loss function. Now you might increase the value of a, the slope of the line, and so the line will be like this, and maybe the loss function is reducing, and if we decrease the value of a, then maybe the loss function is increasing. The distance from the line and the data points are increasing, so we don't want to do that. So we'll just try to increase a, and we'll do that a multiple number of times until we get a best fit line which satisfies our equation, and we can use the line to predict the let's say the estimated price of the apartment based on area. So one important thing is that the relationship between changing the parameters and the change in loss function is called as gradient, and since we are trying to descend the loss function using the gradient, we are calling it as gradient descent, right? Now, this was an extremely simple example based on an extremely ideal world where there was only one parameter, which was impacting the house prices. Now, in an ideal real world scenario, we might have several different factors, right? There might be proximity to a school, hospital, industrial area, or the type of area. All this will directly affect the price of the house. Now, since we get more and more dimensions, let's say three up to 3 dimensional is fine, but after that, when there is 4 dimension, fifth dimension, and so and so, we will not be able to understand the type of equation we need to use, and it will get very chaotic in nature, and which is why computer scientists devised this neural network because it was getting very chaotic. So what a neural network does is it approximates any given mathematical equation given enough parameters, right? Now, we don't need to deep dive into how it approximates the mathematical equation, but it's how it's doing is it's basically using the universal approximation theorem, or UAT, and that's how it approximates the value. But basically, a neural network approximates any given mathematical equation, right? Given enough parameters. And since the equations get extremely lengthy and the information moves from left to right, we sort of like to consider them as neurons. But there is a whole history about neural networks, which I'll like to cover in some future video. So, but for now, we are just trying to understand how they work, right? So, this is the overall mechanism. Now, how the neural network works, right? So, the most simple neural network could have just one input neuron and one output neuron. Let's consider X as the input neuron, and on that we have A as the weight and B as the bias, which gives the output neuron Y. All right, these weights and biases are basically the parameters of the neural network, right? Each neuron computes a new value based on the previous layer's activation. Now, how it does it is basically in two steps. It calculates a weighted sum based on the previous layer's activation and adds a value that decreases or increases the value of the new neuron. This is the bias, right? So the weights and biases are the parameters of the neural network. And here we only had one weight and one bias. But in the ideal world, the frontier neural networks tend to have billions or even trillions of parameters. So you can just understand the complexity. And that is why they are able to generate such amazing outputs. And the reason they become so complex is why we sometimes think of neural networks as these black boxes that we cannot really understand what's going on inside. However, a lot of research is going on, specifically interpretability research. So I'm optimistic about the future that we will get to understand how it's all coming. But for now, this is how the neural network is working. So we understood that AI systems learn from data using gradient descent. Most AI development uses neural networks because they can process a lot more information efficiently, and these can work from narrow classifiers to image generation or text generation, video generation. However, they rely on having a lot of data and computing power available. Better algorithms can drastically reduce the amount of data required or the amount of compute, that is the computational power, which you use. So that's it. Uh, I hope you got to learn something from this video. Thank you so much for watching. Keep an eye for further videos. Bye.